Assalamu alaikum students, I'm your teacher Zain Ali. We will be solving some numericals today. The first numerical we have is if 100 wave pass through a point of medium in 20 seconds, what is the frequency and time period of wave if its wavelength is 6 centimeters? Calculate the wave speed. To understand what is the numerical is telling us, we have a graphical representation of the numerical. Here we have a medium where there is a point where the wave is passing through 100 times. We have to find the frequency, which will be the numbers of wave divided by the time, and we have to find the time period, which will be t is equals to 1 over frequency, and we have to find the speed of the wave. If we find out the frequency, we can use the formula v is equals to lambda f, because we have already the wavelength of this wave. If we find out the frequency, it will be easy for us to calculate the speed of the wave. So first of all, we will write the given data. We will write the number of waves denoted by n, which is equals to 100. Then time is equals to t, which is 20 seconds. Wavelength of the wave lambda is equals to 6 centimeters. Here we have the measurement in centimeters. We have to convert it into the SI unit of the length, which is meters. So there are 100 centimeters in 1 meter. So we will divide the 6 with 100 and we will get the measurement in meters. Now what is required? Frequency of the wave, which is denoted by f, time period of the wave, which is denoted by capital T, wave speed, which is the velocity, denoted by v. We will write the formula to find out the frequency. The formula of the frequency is number of wave divided by time taken. The second formula we use for the time period will be T is equals to 1 over f. And the third formula is the formula of the wave speed, which is v is equals to lambda f. First we will find out the frequency. We will write the number of waves. As you know, 100 waves were passing in 20 seconds, so we will put 100 divided by 20 and the answer will be 5 Hz. For time period, we will use the formula of the time period, T is equals to 1 over f. We will write 1, and for the frequency, we have just find the frequency here. We will put 5 here and we will get an answer of 0.2 seconds. Now for the third formula, which is the formula of the wave speed, v is equals to f lambda, we will put 5 Hz multiplied by 0.06 meters of the wavelength and we will get 0.3 meters per second. The next question is, a wooden bar vibrating on a water surface in a ripple tank has a frequency of 12 Hz. The resulting wave has a wavelength of 3 centimeters. So now we have the both measurement, the wavelength and the frequency, and by using v is equals to lambda f, we can find out the wave speed. So we will write the given data. Frequency of the wooden bar f is equals to 12 Hz. Wavelength of the wave lambda is equals to 3 centimeters. Now the measurement of the wavelength is in centimeters. We have to convert it into meters. When you convert a smaller unit into a bigger unit, you have to divide it, and when you go from a bigger unit to a smaller unit, you will be multiplying it. We will divide the 3 with the 100 because there are 100 centimeters in 1 meter. So we will divide it and we will get an answer of 0.03 meters. What is required? We require the speed of wave denoted by v. We will put the formula v is equals to lambda f and we will start our calculation. We will put the value of frequency and the lambda and we will multiply it and we will get an answer of 0.36 meters per second. So now we will move to the next numerical. A transverse wave produced on a spring has a frequency of 190 Hz and travel along the length of a spring, which is 90 meters, in 0.5 seconds. We have to find what is the period of wave. Period of wave is same as the time period. What is the speed of wave? And the third one is what is the wavelength? So we will write the given data, but before solving it we have to understand what the numerical is telling us. There is a disturbance created on a spring, and disturbance is traveling along the spring, and the disturbance will cover some distance. Okay, so it is a little bit different from other numericals. Now we will write the given data. Frequency is equals frequency f is equals to 190 hertz. Length of a spring, which is a kind of a displacement here, L is equals to 90 meters. T is equals to 0.5 seconds. What is required? Time period of the wave and the wavelength. So first we will find out the time period. The formula of the time period is T is equals to 1 over frequency. For the speed of wave velocity, we will use the formula V is equals to displacement over time. Now you will question me why we are not using the wave speed formula. Till now we do not have the wavelength lambda, so we cannot use the V is equals to lambda f. So as the numerical tells us that the disturbance is traveling along 90 meters in 0.5 seconds, so we can use this formula V is equals to displacement over time, and we will find out the speed. Once we have the speed, we can use the wave formula, which is V is equals to lambda f. So first we will find out T, which is time period. So we will put 1 over 190, and so we will get 0.05 seconds. Second, we will find the velocity. V is equals to displacement over time. We will put 90 over 0.5 and we will get 180 meters per second. The third one is how to find the lambda. So the equation is V is equals to lambda f. Here we want to know the lambda. We do not want to know the wave speed. So we will reset the formula. Here the frequency is multiplying with the lambda. When it goes to the other side of the equation, it will be divided by the velocity. So now the formula is set. So we'll put the data, we will put the velocity which we have just find out, and we will put the data 180 over 90 and we will get 0.95 meters. So here we have found all the results. Numerical number 10.8 is water wave in a shallow dish are 6.0 centimeters long. At one point, water waves move up and down at the rate of 4.8 oscillations per second. What is the speed of water wave and what is the time period of water wave? So we will write the given data. Here you have to understand the 4.8 oscillations per second is actually the frequency. We will write the given data. Wavelength of the water, lambda is equals to 6 centimeters. We will change the centimeters into meters and we will get 0.06 meters. We will write the frequency f is equals to 4.8 hertz. What is required? The speed of the wave, which is equals to V, time period of the water wave, which is equals to capital T. We will write the formula for the speed of the wave. V is equals to lambda f, and we will write the formula for the time period, which is equals to T equals to 1 over f. So we will write the formula for the speed of wave, which is V is equals to frequency multiplied by lambda. We will put 4.8 hertz, which is the frequency, multiplied with the wavelength, which is 0.06 meters, and we will get an answer of 0.29 meters per second. Now we will find out the time period. Time period of the water wave is T is equals to 1 over f, and we will put 1 over 4.8, which is the frequency, and we will get an answer of 0.21 seconds. I hope you have learned the method how to solve the numericals, and there are 2 numericals left which I will give you as a homework, which is 10.9 and 10.10. So hope you can solve it and it will be easy for you. Thank you.